we talked a little bit about the difference of squares. And so we know that the difference of squares works with anything that is in the form of x squared minus y squared. If we see something in the form of x squared minus y squared, we can actually factor it into x plus y times x minus y. So let's look for a second. Let's remind ourselves of some of our perfect squares. This only works with perfect squares. So if I have 1 squared, what is 1 squared? 1. What is 2 squared? 4. What is 3 squared?
9.
What is 4 squared?
16.
What is 5 squared? 6 squared is? 7 squared is?
49.
8 squared is? 9 squared? 10 squared? 11 squared? 12 squared? Ah, what is it? 144. What is 13 squared? What is 14 squared?
180. 196.
The inverse. We've got 13 squared, which is 169, and 14 squared, which is 196. 15 squared is 225. You should know all of these. Good. You should know all of these. You should. These are all fair game. These are all fair game.
Then what about 16?
X. If you see x squared, you get x squared. If you see x, or let me say this, if you see y and it's raised to the second power, you get y squared. What if you see x squared squared? X squared squared would be x to the 4th. Good. If you see y squared squared, you would get y to the 4th. Okay. So, if I give you one of these perfect squares, you can break it down using the difference of squares. Now, what does difference mean? Difference. So the only possible thing that you can have here in the middle, difference, is, how bad did I misspell difference? Really bad. It's really bad. How do I spell it? Diff.
I mean, you spelled it with 3 F's.
Diff. How do you spell it? Is that right?
I think that's
Different.
No. No, there's an A in there
Oh, I
somewhere.
saw. They're just saying, no, it is.
There's an A in there somewhere.
What?
There you go. Oh, 160.
Here, I have it D-E-F. I have it right on the calendar. D-E-F. I had it different. D-E-F-E-R-E-N-C-E. Different. Alright. So, difference of squares. Here we go. If I give you, and there's no, guys, you just recognize it. This is something that you just say, oh, so we have x squared minus 4. How do we if you see x squared minus 4, your brain should go, oh, that's the difference of 2 perfect squares. X squared is a perfect square. 4 is a perfect square. It's minus in the middle. So I factor that into x, 2 plus minus. That's what you should do. X plus 2, x minus 2. That's how easy it is. If you see x squared minus 81. Or if I change this to y squared minus 81. Your brain should say y squared is a perfect square, 81 is a perfect square, they are subtracted, so y, 9 plus minus. And how can I check myself?
Multiply the y together and the y together.
Okay, we can't just multiply the y's and the 9's together because how do we multiply? We have two ways to multiply a binomial. One is the box method. Hannah? What is y times y? Grace, what is y times negative 9?
No, I didn't do that. Why? Negative 9y.
Lauren, what is 9 times y? Skylar, what is 9 times negative 9? And if we were to write this out, we have y squared minus 9y plus 9y minus 81. These do what? They cancel. And that's why my answer is what? Y squared minus 81. So does it check? Yes. Alex, what's another way we can multiply? Okay. We can't. But this isn't a trinomial. We can only use the greatest common factor works. But do these two terms have a greatest common factor? We don't have a greatest common factor, and we don't have a, it's not in our ax squared plus bx plus c, right? It's not a trinomial. So when we see something in the x, perfect square minus perfect square, that's when we say, oh, so if they're perfect squares, you have to recognize it's a difference of squares. FOIL is what I'm looking for, guys. If you have x plus 2 times x minus 2 and you want to multiply these two to check, you want to check your answer, you can FOIL them. First outer inner last. X times x gives me x times negative 2 is 2 times x is, and 2 times negative 4 is. So what happens to my positive 2x and my negative 2x? They're going to cancel out and leave me with my x squared minus 4. So does it check? Yes. Alright, let's look at a couple of more examples real fast. If I give you x squared minus 225, x squared minus 225, how do we factor that? X and x, what's 225? What's the square root of 225? So 15 and 15, and then 1 is a plus, 1 is a, that's it. That's all you got to do. What if I give you y to the 4th minus 49? Y to the 4th minus 49. Y squared and y squared. What's the square root of 49? And 1 is a 1 is a minus. Now, yes, Pauline?
Does it matter on which
No. No. What property says it doesn't matter? Commutative property of multiplication. What is the square root of 9x squared? 3x and what's the square root of 25y squared? 5y and 1 is a, that's it. That's it. Difference of squares is like the easiest factoring of all. All you do is say, oh, that's a perfect square. Oh, that's a perfect square. But if you don't know your perfect squares, then guess what? You're in trouble. Row is correct. Do you have homework?